Okay, in today's lesson, we're going to be putting everything together that we've been learning so far in Unit 10 to solve a right triangle. Now, solving a right triangle means that you're going to find every single angle, every single side length. So, let's just review all the techniques and methods that we can do to find missing side lengths and angles of a right triangle. One thing that I want to talk to you guys starting off is you'll notice a bunch of letters here on this triangle in your notes. The capital letters are always going to correlate to angles. So this capital A represents the angle, capital C represents the angle, capital B represents the angle. These lowercase letters, they represent the side lengths. Now, if you know angle A is like this top angle, the side length A will always be the angle that's right across from it. Angle C will always be across from side length C, and angle B will always be across from side length B. So that's just a way that we're going to label and talk about our side lengths today in our triangles. Okay, so let's say I give you a right triangle, and you know the measure of one angle and the length of one side. So it's going to look something like, say you know this angle and you know this side. You have to find the other angle and the other side. So for the third angle, it's going to be pretty easy. You're just going to subtract from 180. To find the lengths of the other sides, first you have to use SOHCAHTOA. Then you'll know two sides. So then you can use Pythagorean theorem. Okay. And we will do examples of both of these when we get to the next page. Let's say I give you a triangle where you know two of the side lengths. So something like this, 7, 10. To find the length of the third side, that part's pretty easy. You're going to do Pythagorean theorem. And with Pythagorean theorem, generally you're going to want to leave your answer as a square root unless it tells you to round it. Then to find the measure of the angles, first you have to use inverse trig. And this is the sine, cosine, and tangent that have the -1. And then that will help you find the second angle, and then to find the third, you're just going to subtract from 180. Okay. So let's do some examples of it. Again, we've already done all of these different methods, so we're not going to be using anything new to solve these right triangles. We're just going to be doing multiple in the same problem. So let's go ahead and take a look at our triangle here. First of all, our angles are labeled with the capital ABC. I'm going to go ahead and label the sides, lowercase a, b, and c. And what you can start with is you can fill in all the information that we know. So this down here means the measure of angle A, which I don't know. However, the measure of angle B I do know to be 65 degrees. And the measure of angle C is the right angle, so that's going to be 90 degrees. As far as side lengths go, I only know the value of B, which is 8.6. And now my job is to find all the other missing pieces. So I have 3 pieces that I need to find. Think about this as 3 like little mini problems. I'm going to do each one in a different color. Let's solve for angle A first. I know 2 angles of my triangle, so I just need to find the third. So I'm going to do 180 minus 65 minus 90. I'm going to grab my calculator out. And I get 25. So the measure of angle A is 25 degrees. Okay, let's look at finding a side length now. Now I have to find side length A and side length C. It doesn't really matter which one you start with. So I'm just going to start with side length A. When I do this, I like to put a little X next to the A so that I indicate, yeah, that is the one that I'm looking for right now. So I'm going to have to use SOHCAHTOA. sine, cosine, tangent. So I'm going to put my theta by my 65-degree angle, and then label my sides, opposite, adjacent, hypotenuse. Then I'm going to look at what I know. I know the opposite, and I decided that I wanted to know the adjacent. So that's the tangent. So I'm going to say the tangent of my 65-degree angle is equal to the opposite, 8.6, over the adjacent, which is my x value. Go ahead and multiply both sides by the denominator of my fraction to get rid of it. So x tangent of 65 is equal to 8.6. Divide both sides by the tangent of 65. So x is equal to 8.6 divided by the tangent of 65, which is 4.01. Let's check the instructions really fast. We want to round our answers to the nearest tenth. That's the nearest decimal, nearest one decimal. So this one's just going to round to a solid 4. Okay. Now I need to solve for side length C. Since I know A and B, I can just use the Pythagorean theorem. So 4 squared plus 8.6 squared is equal to C squared. Grab my calculator. 4 squared plus 8.6 squared is 89.96. Take the square root of that, and my C is equal to 9.5. Okay. And that is what it looks like to solve a right triangle. So I used a few different methods, and I was able to find every missing side length and every missing angle. Okay, let's do another one. Go ahead and start by labeling your sides. The side across from angle A is side A, across from B is side length B, and across from C is side length C. Then we can fill in what we know. Angle B is a 55-degree angle, and angle C is a 90-degree angle, and then side length C is 11. Generally speaking, you are going to have 3 pieces of information filled in and 3 pieces of information that are missing. Let's start by finding our angle. 180 minus the 2 angles that I already know. Going to give me 35 degrees. So angle A is 35 degrees. Now let's find a missing side length. So I'm going to go ahead and put my theta where my 55 degrees is. And then I've got to decide, do I want to solve for side length A or side length B? And again, it doesn't really matter which one you solve for, because you're going to get to both of them eventually. Let's start with B this time. So put an X by B or something to indicate that that's the side length that you're using. I forgot, I need to label my sides, opposite, adjacent, and hypotenuse. And now I'm going to use my opposite side, because that's my X value. And I'm going to use the hypotenuse, because that's the one that I know. So opposite and hypotenuse, that's the sine. So the sine of 55 degrees is equal to the opposite over the hypotenuse. I'm going to multiply both sides by 11. I get 11 sine of 55 is equal to x. Once the x is by itself, I just type that into my calculator. I get 9.01, which is just going to round to 9. Okay, I need to find my last value, so I need to do the Pythagorean theorem. So a squared plus b squared is equal to c squared. I'll do some squaring. Some subtracting. So b squared is equal to 40. Then I'm going to square root both sides. Now, at this point, usually I'd want to simplify that square root, like break it into factors, look for pairs of numbers. But since the question instructions say round to the nearest tenth, that means I can just punch that into my calculator and get a decimal. So that's where it kind of pays to read the instructions, figure out what it's asking for. Okay, so those are two examples of when you know one side and one angle. So let's go ahead and kind of do the opposite or the other option. The other thing that you can have is that I can give you a triangle that just has two side lengths, like we have in examples C and D. So let's start by labeling my sides A, B, and C, and then filling in all the information that I know. I know angle C is 90 degrees. That's the only angle I know. And then I know side length A is 15 and side length B is 13. And I just have to choose somewhere to start. Do you want to start with your angles? Do you want to start with your side lengths? I'm going to go ahead and start with my angles. Let's kind of start with angle A. If you want to solve for angle A, you put your theta, let me get a red marker. You're going to put your theta in angle A. Your theta goes by whatever angle you're trying to find. Then label your sides, opposite, adjacent, hypotenuse. Decide which sides you're going to use. So I know the opposite, I know the adjacent. Well, that is the tangent. So the tangent of theta is always equal to the opposite over the adjacent. So to find my theta value, remember this is when I pull in my inverse tricks, the tangent with the -1. So inverse tangent of 15 over 13 is equal to theta. We punch that into our calculator. We make sure that we're in degree mode, and you should get 49.1 degrees. And that goes in angle A. Now be careful when you do these problems. If you, whatever value you get for theta, that is the value of wherever you put your theta. So if you would put your theta in angle B, then you would be solving for angle B, but we put it in A, so we found angle A. All right, let's finish up our angles now. I now know two angles, angle A and C. I just need to know my third. Now I can just subtract from 180. So 180 minus 90 minus 49.1. That gives me a 40.9. So that kind of finishes off my angles for me. Now I just need to find the third value of the sides, which is also going to be fairly straightforward. I can just use Pythagorean theorem. So a squared plus b squared is equal to c squared. I'm going to square 15 and 13 and add them together. So 394 is equal to c squared. Take the square root of that. And again, I just need a decimal. That's going to give me 19.8. And now that triangle is solved. All right, let's do another one. So I'm going to start by labeling my sides, A, B, C, then filling in all of the information that I know. And now you can basically choose where do you want to start. So I'm going to start with the angle again, just like I did in example C. But you can start with finding angle A, angle B, or side length A. You're going to get the same answers regardless. If I want to start with solving for angle A, I'm going to put my theta in angle A. Label my side lengths, opposite, adjacent, hypotenuse. Decide which sides to use, which are going to be the two that I know. So I'm using the adjacent and the hypotenuse, which is the cosine. So the cosine of theta is equal to the adjacent over the hypotenuse, which means that the inverse sine of 5 over 8 the inverse cosine is going to be my angle. So that works out to be 51.9 degrees. So the measure of angle A is 51.9 degrees. Okay. To find angle B, that's going to be my easy one. I can just take 180 and subtract the two angles that I already know. I'm going to get 38.8 40.1. So that's my angle B. And now I need to find my side length. So I'm going to do that up here to the right of the triangle. I don't know A, so I'll just leave an A squared there. Plus my B squared is equal to the C squared. Go ahead and square the numbers that I know. So A squared plus 25 is equal to 65.61. Subtract the 25. So A squared is equal to 40.61. I'm going to square root both sides. Square root of 40.61. And my A is equal to 6.4. So go ahead and fill that in here. Okay, this is enough for you guys to get through the first 4 problems of your homework. So I want you guys to pause here, go do the first 4 problems of your homework, and then come back and we'll talk about how to do numbers 5 and 6 in your homework.